feature extraction techniques. It's used to convert text data into numerical feature vectors with a fixed size. Let's see how it works by considering a document where we need to extract text features. The steps to follow are: assign a fixed integer ID to each word by splitting them into several words, also known as tokenizing. Then, count the number of occurrences of each word or token. Finally, store it as the value feature in matrix format. The matrix presentation on the screen shows how multiple documents and tokens are structured. Shows how the count vectorizer algorithm works in sllearn. The goal is to convert a collection of text documents to a matrix of token counts. There are several parameters which affect the vectorization process. Let's take a look at the components of the signature. Input content. The input content can be a file name of the sequence of strings which needs to be vectorized. Encoding. The default encoding is UTF-8. The encoding is to decode the input. Strip accents. It removes accent present in the code. Tokenizer. It overrides the string tokenizer method, but the default value is none. Stopwords. It's a built-in stopwords list that is used. Max threshold. It indicates the terms or words that appear more than a given threshold value and should, therefore, be ignored. Min threshold. It indicates the terms or words that appear less than a given threshold value and should, therefore, be ignored. In this demo, you'll learn how to process documents using Bag of Words. Let's start by importing the required library Count Vectorizer class. This class helps tokenize the document. It converts the text into vectors by assigning numeric values to each word. Let's create an object vectorizer by instantiating the Count Vectorizer class. Next, we'll create 3 random documents. Let's add some text to the documents. Document 1 can have, "Hi, how are you?" In document 2, we can add, "Today is a very, very, very pleasant day, and we can have some fun. And in document 3, we can say, "This was an amazing experience." Now, put all 3 documents together as a list. Next comes the interesting part, which is creating the bag of words for the list of documents. This is done by accessing the fit method and fitting the documents into the vectorized object. We'll move on to accessing the transform method and transform the list of documents. Now, let's print the bag of words and look at the details. You can see the properties of vectorized object. As you can see, the first number is the tuple and the second number is the frequency of words. The tuple here indicates the document number and feature indices of each word which belongs to the document. Feature indices are generated from the transform method. This is a feature extraction process, and to extract the features, you have to refer to the indexes, which is assigned to any particular feature. Next, let's check for repeated words in the vocabulary that is built with the get function, and then print it. Finally, check the bag of words type for the documents. The output displays sparse matrix, and it falls under SciPy. In this demo, you learned how to use bag of words technique and transformed documents using the transform method. sparse. You may at times come across sparse data, which is an indicator that the resulting matrix will have many feature values that are zeros, and we can use the SciPy sparse tool to handle such a matrix in memory. This is very common when it comes to extracting feature values, especially for large document datasets. Typically, documents use a very small subset of the words used in the corpus. Vectorizer. While using text feature extraction, you will have to tokenize words in a document. A vectorizer can tokenize and count the occurrence of tokens. Words with minimum 2 letters get tokenized. We can use the analyzer function to vectorize the text data. TF-IDF. The next important utility to consider while applying text feature extraction is TF-IDF. It's a popular term weighing utility for term frequency and inverse document frequency. Term frequency indicates the frequency of a particular term in the document. Inverse document frequency is a factor which diminishes the weight of terms that occur frequently. TF-IDF reflects how important a word is to a document. It's directly proportional to the number of times a word appears and is offset by frequency of the word in corpus. Decoding. Each text file can have different decoding. This utility helps decode text data by supplying proper encoding detail of the file. There are different kinds of encoding, such as ASCII, UTF-8, and UTF-16. To work with text files, these encodings need to be properly decoded to character sets called Unicode so that they can be understood by programs. The next feature of sllearn is model training. An important task in model training is to identify the right model for the given dataset. sllearn provides a range of models to choose from and also trains them by using the extracted features from the dataset. The choice of model completely depends on the type of dataset. The models can be trained as a supervised learning model or unsupervised learning model. Supervised learning model. For a given dataset, we'll have observations, features, and response. In supervised learning, we make use of all three tasks: predict the outcome of new observations and datasets, understand which predictors affect the response or outcome, and generalize the data and find the right answer. Generalization is also known as making predictions. Models can be trained to classify the documents based on the features and response. For example, naive Bayes, SVM, linear regression, and KNN neighbors. Unsupervised learning model. In this type of learning, the response or the outcome of the label of the data is not known. There is no definite or right answer in this model. So here we try to train the model by following a few steps, such as understanding the structure of the data first and identify the pattern in the data. Finding predictors that behave in the same fashion or have some familiarity. Exploring the dataset, and the goal is representation of the data. Representation is also known as extracting structure. Unsupervised model can also be used to group